Lesson 3 is called Linear and Nonlinear Relations. So a linear relation, linear just means a straight line. So a linear relation is a relation between two variables that forms a straight line when graphed. If we do have a scatter plot, these points aren't making a perfect straight line, but the trend is really suggesting that we see that this is a straight line going up and to the right. We can draw a line of best fit. So that's a straight line that comes close to the points on a scatter plot. So some teachers might say there should be a few points above and the same number of points below. You're trying to get the line between all of the points as best you can. There are official calculations that you can do to come up with exactly where the line should be placed. But for us, we'll just use a ruler and we try and get the line in between the points so it's kind of looking like it's an average. Okay, we have our independent variable and our dependent variable. If we see a scatter plot and we see all of the points are kind of coming down, but it looks more like a curve, then it's not always the case that you would draw a line of best fit between all the points. Sometimes the data that you have really suggests that this is a curve that you see. So that's a curve of best fit that you could draw. So for us, we're going to call a straight line. We would look at this and suggest that this is linear. And when we look at this here, we would say this is just non-linear. For grade 9, we don't really have to analyze what this is, what kind of a curve it is. That's for later grades, but for now we just know our relations are going to either be linear or nonlinear. So example 1, why is a line of best fit not a good model for the data? When we look at this one in part A, there's only 4 points. I know that the line is going through the points and that's what you are supposed to do, but I just don't think there's enough data there to suggest that this is definitely going to make a straight line. I think you'd need a lot more data points to make that conclusion. This next part B here, I really think that these points look like they're making more of a curve of best fit. So drawing a line, there seems to be quite a few down here further away from the line underneath it. So, I mean, we are getting an average number of points above the line and below the line, but this really looks like it should be a curve. And what we see here in the last example, this just looks sort of random that somebody would draw a line of best fit through all the points that is going down. I mean, someone else could have drawn one going up. These points are really scattered all over the place. I don't see where the pattern is or the trend for that graph. So the data points have no pattern and they don't follow a curve or a line. Example 2, we have a lizard living in the Amazon rainforest. Research found that this lizard keeps its body temperature close to the temperature of its surroundings, and the table lists data from the research. So surrounding temperature, this, because we came to it first, this would be our independent variable. This is our x, or our horizontal axis, and this is definitely going to be our y-axis. So we have the surrounding temperature, and the warmer it is, it's going to actually cause the lizard's body temperature to go up. So the lizard's body temperature depends on the surrounding temperature. So the body temperature of the lizard is the dependent variable. So it is asking you to graph this data using pencil and paper. This could also be typed into Excel. This would be your X column of numbers and then your Y column of numbers. And Excel could graph this for you. I did do this earlier. So I have a title, and then down below I label each axis. So surrounding temperature, and I put units if I have them. They're both in degrees Celsius, and the lizard's body temperature. And I'm just doing my best, right? I break the graph because I started at 24 degrees Celsius because my numbers only went from around 24 up to about 30 as far as the surrounding temperature. And then I started at 26 and went up to 30.5. So this was my graph. I'm doing my best to put my points as accurately as I can. And then I did draw a line of best fit. So the line of best fit doesn't have to start at the bottom corner, at the origin of the graph. It can start up higher. It could start down here. This line of best fit was just a little bit above, between 26.5 and 27. And I thought that that looked the best. I wasn't too worried about this point down here because it looked a bit like an outlier. And all of my points are kind of suggesting this upward trend. So how are the two variables related? Is this relationship linear or nonlinear? I did think that it did suggest a linear trend. So as the surrounding temperature increases, the lizard's body temperature increases. And I do think that this is showing a linear relationship. So draw a line of best fit. You saw that I did that on the previous graph. Estimate the lizard's body temperature if the surrounding temperature is 26 degrees Celsius. So the surrounding temperature is 26. So we're going to, this is interpolation, we're going to look within our graph. The surrounding temperature is 26. So here's our surrounding temperature. We don't actually have a point right above the 26. But we could estimate that maybe it's about 28.5 degrees. If you said something around 28 or you said 29, something in that range, that would be just fine. So I think about 28.5 degrees Celsius from the graph that I have. Estimate the lizard's temperature if the surrounding temperature is 35 degrees Celsius. This is extrapolation because this is going to go beyond our graph. So the lizard's temperature, if the surrounding temperature is 35. So when I look here, I only went up to 30 for the surrounding temperature. So if I go another 5, it'd be kind of at the end of this graph. So you could imagine or even draw your line straight until it was about up here somewhere. And so this is just a prediction. It looks like maybe 31 is there. I'm thinking about 32 degrees Celsius. Just an estimate. You have to be in the right sort of ballpark.